right, we're working on factoring. It's now time to look at trinomials where a is not 1. So basically what that means is you have a constant in front of x squared. So you can't take out common factors or anything like that. You're basically stuck. So let's do some simple ones to start with. There are some that get a little bit more involved. We'll see how that goes here in a minute. Make sure you know how to factor trinomials where a is equal 1 before you attempt these, because those skills will definitely benefit you with these harder problems. When you see the 2, that should kind of set off a flag in your head. This is going to be a little bit tougher. And in all honesty, in my class, we end up calling this something weird. We call it the monkey face problems, and it's because, well, in the process of solving it, we ended up drawing something that looks similar to a monkey's face. So, yeah, these are dubbed the monkey face problems. We're going to go ahead and start trying to factor, because if you attempted to get out something common, you should notice fairly quickly there is nothing common. 2, 5, and 3, they're all prime numbers. So number doesn't work, and 3 doesn't have a variable, so you can't take a variable out. So this is our only option. So just look at the first term. You have to force that to happen. What 2 things can you multiply together and come up with 2x squared? Basically, you know they're going to be x's from what we've done with the other problems. You're looking at 2. What are the factors of 2? 1 and 2. Now, if it makes you feel better to put the 1, then put the 1 so you can see it. Now, I'll go to the back end, and you've got to force that to happen. What 2 numbers multiply to 3? 3 and 1. Now, before you rush and you throw those in your problem, on these, it matters where you put them, because you have already staked a claim for your 2 and your 1. So you've got to know who matches up with the 1 and who matches up with the 2. It makes a big difference, because what you're trying to force to happen is you want these 2 little middle terms here, this product and this product, you need those to add to 5. And it's got to be perfect. It can't be below or close. That doesn't work. It's got to be perfect. 5. Now think about it. If you put the 3 in the back end, that's going to be 2x times 3. We're already at 6x. This is like Price is Right. You went over. So you don't win. So take that out. Sometimes this is called trial and error, because it would be helpful to have an eraser. It's one of those things you just get better at with practice. Now, just test it. 3 times 1x is 3x, and 2x times 1 is 2x. Do these 2 guys add to give you 5? Yes, they do. You've got everybody in the right spot. All you need is signs. Well, let's remember our sign rules. If there's a plus sign in the back, that means your answer signs are the same. You look up front of your problem. That tells you what both answer signs will be. You need a plus and a plus. So I know that looks kind of messy. You're welcome to rewrite it. So if that just kind of doesn't suit you to be kind of messy, do a rewrite, clean it up. There you go. You got 2x plus 3 and x plus 1. They have to be that way. What I mean by that is the insides have to be the same. You could turn it around. As long as each factor, you have to have an x plus 1 factor, and you have to have a factor of 2x plus 3. Okay? Now, it can get more interesting. Let's see here. What if, excuse me. Basically, if you've got numbers that aren't prime. See, in that problem, we had things that everything was prime, so it just worked out just fine. If it's not, then we've kind of got a problem. So here we go. We got 4x squared plus 16x plus 15. A little bit nastier. Okay. The good thing is I'm still keeping you with the plus sign in the back. If this was a minus sign up front, it's really not going to increase your difficulty. This kind of makes everything a little bit easier. You can check it just for the sake of checking. Can you pull out anything common? 4 and 16 are common, but 15, not so much. And you can't pull a letter either because, well, 15 doesn't have one. Now, you have options when you come in here for 4x squared. You could use 4 and 1. You could use 2 and 2. And sometimes you just may have to try them all. You got to try every combination there is to make it work. Well, I will say this, just somebody who's older and done this for a long, long time. If you're just starting out, I would choose the pair that's closest together. Most of the time, it's the close pair. Very rarely is it the pair that's pretty far apart. So I would go with the 2x and the 2x. Now, when you come back to the back end, you got 15. Same thing. It could be 1 and 15. It could be 3 and 5. My suggestion to you as somebody that's old and done this a long time, use the close pair. So the question is, do we do 3 and then 5, or do we do 5 and then 3? Let's think. We want these two to add to 15, and it's got to hit it spot on. So if you put your mind to it, let's think 2 and 5 make a lovely pair, because that brings us up to 10. That leaves the 3 here. 3 times 2 is 6x. Yes, these guys do add to 16, so they're perfect. Since we have a plus in the back, that means our answer signs are the same. They're both going to be minus in this case. So if you kind of like your paper a little bit cleaner, just rewrite to make it pretty. There you go. You have to have those two factors. They do not have to be in that order, but you do have to have a 2x minus 3, and you do have to have a 2x minus 5. Now, the only thing you've got to watch out for is having a negative in the back. Because if you have a negative in the back, it sure does make things a little bit more complicated. I'm trying to work one out right quick so that we can see how that goes. Let's try this one. We've got 2x squared, and then that's going to be, let's put a 5x here, and let's do a minus 12. Okay? Check it for something that's common. We don't have anything because 2 and 5 are prime, and 12 doesn't have a letter. Now, what two numbers multiply to 2? Well, that'd be 2x and x. Now, what two numbers multiply to 12? Oh boy, lots of choices. 2 and 6, 3 and 4. Okay. Again, my advice: if you don't know where to start with the closest pair. Now, we got to position these things so that the middle terms subtract to 5. So they can't be too close. If I'm going to start with the 3 and the 4, if I did 3 times 2, that would take me to 6. And that would be 4 times 1. 6 minus 4 is not big enough. So let's put the 4 here and the 3 there. 2 times 4 is 8x. 3 times x is 3x. Do these two subtract to 5? Yes, they do. So you've got everything in the right place, and that's a big deal. Now come back with your signs. The signs will be different. The big pair, not the big number, the big pair needs to be plus. And what I mean when I say the big pair, these things down here, which one of these is larger? He needs to be the plus sign. This one needs to be the minus. So basically it depends on which number in the back helped make the big pair. Was it 3 that helped make the 8, or was it the 4 that helped make the 8? Well, if it's the 4, you can trace it back along this line. He gets that sign. The other sign goes there. So if you need to clean it up, you have to have a 2x plus 3, and you have to have an x plus 4. All right? Now, there are going to be some where it works out to just be a little bit tricky. I'll just tell you now, it's not going to feel right. So I want you to be careful on these. You got 2x squared, and you've got a plus x, and then you've got, let's see here, minus 6. And I'm hoping this works out to do what I'm wanting it to do. We'll see. Here goes. I'm wanting to put one of the tricky ones up here. I think this is it. If you multiply to get 2, you gotta have a 2x and an x. What two numbers multiply for 6? Well, you can list them out over here. Again, I would vote for the ones that are close. I'm not saying it's always going to happen, it's just normal. Now, here's your little monkey face. I don't know if y'all picked up on the monkey face or not. Your products down here have to subtract to be 1. So if I'm going to use the 2 and the 3, I need to match the 2's up, that gives me a 4. Put the 3 here, that gives me a 3. So do these subtract to give me 1? Yes, they do. Everything's in the right spot. Now, here comes the weird part. The signs have to be different, so the big pair gets the plus. With a big pair, 4 is bigger than 3. 4 gets that plus sign. Well, who helped make it? It was the 2. Now, and that may not seem strange to you, unless you go back and you look. Make sure that you understand it's the big pair that got that sign, because 3 is actually larger than 2. So if you had gone with the old rule of the big number in the back gets that sign, then your signs would be backwards. So make sure it's the big pair and which number in the back of your binomial helped make it. And you could clean it up. But just be really particular about your signs. You can always multiply it out to check. You never really have to feel like you're shooting in the dark or guessing with these. Just multiply them out. Have fun.